Intermolecular forces are weak attractions between molecules, but despite being weak, they still strongly influence the physical properties of substances. In this presentation, we will explain dipole-dipole forces and how they work using our model and why they affect physical properties such as boiling point and solubility. Dipole-dipole forces occur between polar molecules. A polar molecule has an unequal distribution of electrons which creates a partial negative end and a partial positive end called the dipole. When we look in our model, delta positive represents the partially positive region and the side marked delta negative represents the partially negative region. These opposite charges attract each other. The positive end of one molecule is attracted to a nearby end of another molecule. This attraction is what we call a dipole-dipole force. When polar molecules are close to each other, they tend to align so that the opposite charges are facing each other. This alignment lowers the energy level of the system while making it more stable. However, these forces are still relatively weak. They are much weaker than ionic or covalent bonding, which means that they can still be broken down by heat or motion. This weakness explains why dipole-dipole force does not hold them permanently but keep them loosely attracted. Despite being weak, they can still affect measurable physical properties. For example, boiling point. Substances with higher dipole-dipole force generally have higher boiling point because more energy is required to separate the molecules. Another one is solubility, because polar molecules tend to dissolve with other polar molecules because of the dipole-dipole attraction that forms between them.
At the starting of the week at Summit Talk Show.